Welcome to the third video of 20.1. So we're just going to look at the electrochemical series on this. So it's just one slide. It's not going to take very long. So sometimes we list the half equations and their electrode potentials in a series, so in a list, and we call that the electrochemical series. So in this example, we've got the most positive at the top, and then we've got the most negative at the bottom. Sometimes it's written the other way around, and sometimes in an exam they'll give them to you all mixed up just to confuse you. So they're always written as reduction potentials, so they're gaining electrons. So because they're written with the electrons on the left-hand side, anything on the left-hand side of the arrow is going to be an oxidizing agent because it's taking electrons and it's taking those electrons from something else. So it's causing a loss of electrons from something else. So anything on the left-hand side of any of these arrows is an oxidizing agent. And anything on the right-hand side, if we reversed it, would be a reducing agent. Because if you reverse that reaction, it's giving up the electrons. So it's causing something else to gain electrons. So it's going to be a reducing agent. Now you'll notice in these, the arrows are single arrows, so they're normal reaction arrows. Now in the electrochemical series and in an exam, they're normally written as these single arrows, but in reality, they're actually reversible. So really, these should all be written with our, sorry, I've not got my pen on yet. So they should all be written with this reversible arrow. Sorry, that's not a very well drawn arrow. So when we've got these reversible arrows, whatever's on the left-hand side is going to be an oxidizing agent. What's going to be on the right-hand side is going to be a reducing agent. So the more positive it is, the better it is at accepting electrons. So the better oxidizing agent it's going to be. And the more negative it is, the better it is at giving up electrons. So it's going to be a better reducing agent. Now, if you want, we'll look at this in more detail on how to use the electrochemical series in the next lesson. But if you want to work out the voltage between that's obtained when you combine two of these half cells, it's just the difference between the two values. So, for example, if I was to connect this one here, so if I was to connect this gold one with this fluorine one at the top, then the difference between that is 2.87 minus 1.50. So that's going to be 1.37. So the potential difference between the two would be 1.37 volts. We have to be careful if we're doing something that's a negative sign here and a positive there. So for example, if we had, let's say we had this mercury one here, and we had this lead one here, then the difference between those is 0.27 minus, but it's minus 0.13. So it's actually going to be 0.4. So if you connected those two together, you'd get a voltage of, or potential difference of 0.4 volts. And we need to be able to determine which is the most negative value, because that's going to be the negative electrode. So if we connected these two, if we go back to that example, this is, even though that's positive, this one here is more positive, so this would be the positive electrode, and this one would be the negative electrode. And it's easier to see if you've got one value that's positive and one that's negative. So if we had these two connected, this would be the positive electrode, and that would be the negative electrode. Okay, thank you for listening. See you next time.